Find a quadratic equation whose roots are 4 and 8.
Fat Math, the right path to develop the fat brain that you've got. Hello everyone and welcome to Fat Math TV.
In this video, we will have the sum and the product of roots of quadratic equations. Consider the following quadratic equations. 1. X squared minus 4x plus 3 equals 0. 2. X squared plus 2x minus 8 equals 0. And number 3, 2x squared minus 5x minus 12 equals 0. So you can identify the roots by different techniques, by factoring, using completing the square, or by using the quadratic formula. So for convenience, all the examples here are factorable, so you can factor this quadratic equation. So we can factor this expression here. X squared minus 4x plus 3 can be factored as x minus 3x minus 1, which gives us roots 1 and 3. Positive 1 and positive 3. And for the second one, we will have there x plus 4 and x minus 2, which gives us roots negative 4 and positive 2. And lastly, in number 3, we can factor this as 2x plus 3 and x minus 4, which gives us roots negative 3 halves and 4. If you will add the roots 1 and 3 of the first equation, you will get 1 plus 3 equals 4, while the product, if you multiply them, is 3. So the sum of the roots is 4, that's 1 plus 3, and the product of the roots is positive 3. That's 1 times 3. For the second equation, the roots are negative 4 and 2. The sum of negative 4 and 2 is negative 2. So that is the sum of the roots of this equation. And the product is negative 4 times 2. That is negative 8. And lastly, for our last example, the sum of roots of negative 3 halves of this equation. So you will have negative 3 halves plus 4. That is positive 5 halves, because this 4 is 8 halves. Negative 3 halves plus 8 halves is 5 halves. And then the product, you will have negative 6. You just multiply negative 3 halves times 4. Okay, so what we're going to do in this lesson is we will identify the pattern. So for example, the sum of the roots is 4. The sum of the roots is negative 2. The sum of the roots is 5 halves. As what you can see here from the given equation, we can identify the sum of the roots. We can see here that this is 4, the sum of the roots, and we have a term here with negative 4. This is negative 2. We have a term here that has a positive 2. And then here, 5 halves, here we have here negative 5. It just has over 2. So what do you notice? How do we get the sum of the roots of a quadratic equation given the equation without actually looking at the roots, without actually finding the roots? So we can see immediately from the given equation that the sum of the roots is just here, the coefficient of x. It's just that it has the opposite sign of the coefficient of the term with x in this case. In the second one, in the example, it's just the negative of the coefficient of x, while in the third one, it's negative of the coefficient of x, but it has over 2. So that over 2 is coming from this coefficient of x squared. Actually, here the coefficient is 1. Here it's also 1. So you can have 4 over 1, that's 4. And for this case, 2 over 1, that negative 2 over 1, that's negative 2. And then lastly, for this example, that's negative of negative 5 over 2. And for the product of the roots, you can just see it there in the constant term. So the product of the roots in this equation is just this 3. It's also 3. And then for this one, it's negative 8. So it's also negative 8 here. While in the last one, it's 12 here. And our product is negative 6 because we still have to divide by 2 by the coefficient of x squared. So negative 2 over the coefficient of x squared will give you negative 6. So in general, if you have ax squared plus bx plus c equals 0, without actually finding its roots, you can identify the sum or the product of the roots of this equation. Okay, so those are the roots by using the quadratic formula. It's just the sum of the roots is b over a negative b over a. The negative of the coefficient of x over the coefficient of x squared. While the product of the roots is just the constant term divided by the coefficient of x squared. So what we did here is we had this by observation in the pattern that we have in the 3 examples. But we can also derive these sum and product of roots using the roots of a quadratic equation ax squared plus bx plus c equals 0 using these roots from the quadratic formula. So the roots of this quadratic equation ax squared plus bx plus c equals 0 is negative b or our negative b plus square root of b squared minus 4ac over 2a and negative b minus square root of b squared minus 4ac over 2a. Okay, let us derive that. So the sum of the roots, as what we have observed, is just the negative of the coefficient of x over the coefficient of x squared. Let us verify in this slide that indeed the sum of the roots is negative b over a. So here we have the roots x sub 1 and x sub 2. If we add them, we will have negative b plus square root of b squared minus 4ac over 2a plus negative b minus square root of b squared minus 4ac over 2i and 2a. And these are similar fractions because we have the same denominator, so we will just add the numerators. So if you will add the numerators, as what you can see here, we have negative b and negative b, and then positive of this whole thing plus its negative will be 0. So negative b minus b is just negative 2b. Okay, so this positive square root of b squared minus 4ac and the negative of the square root of b squared minus 4ac will just be 0. And the negative b plus negative b is negative 2b. And then we can cancel 2. And that will give us negative b over 2a. So indeed, for a quadratic equation, ax squared plus bx plus c equals 0, the sum of the roots is negative b over a, or negative of the coefficient of x over the coefficient of x squared. How about for the product of the roots of this quadratic equation? So if we multiply the roots, x sub 1 and x sub 2, we will have negative b plus or square root of b squared minus 4ac over 2a times negative b minus square root of b squared minus 4ac over 2a. And then if we are multiplying fractions, just multiply the numerators, multiply the denominators. For the numerators, what you can see here, we have a term plus another term times the same term, first term, but this time minus the same second term. Meaning to say we have the sum and difference of the two terms. So if you have sum and difference from the special products, the product is the difference of the squares of the terms. And the square of negative b, that's the square of negative b minus the square of this second term here. So difference of the squares. And then for the denominator, you have 2a times 2a, that's 4a squared. The square of negative b is b squared. And then the square of a square root is just what is inside. So b squared minus 4ac. So if you have square root squared and the squared will cancel. you will have b squared minus 4ac, but you should not forget to distribute this minus sign here. So you should put parentheses first and then distribute the negative sign. You will then have b squared minus b squared plus 4ac over 4a squared, and then that will give you 0 plus 4ac, or that is 4ac. And then you can cancel the 4a and the 4a, and then if you cancel a here, you'll cancel 1a, and then you will be left with c over a. So indeed, the product of the roots is c over a. Okay, let's have examples. Find the sum and product of the roots of the following quadratic equation. So this time, we will no longer find the actual roots. They may be real numbers, rational numbers, equal, unequal, or they can also be irrational numbers and imaginary numbers or complex numbers. So what we're going to do is, without actually finding the roots, we will identify the sum and the product of the roots by using the formulas that we have derived. That is, the sum of the roots is negative b over a, and the product of the roots is c over a. So it's important here that you should know how to identify b and a and c in the equation. So a is the coefficient of x squared, b is the coefficient of x, and c is the constant term if the equation is written in standard form: ax squared plus bx plus c equals 0. If the equation is not written in standard form, like in this case here, x squared equals 7x plus 2, then you should write it first in standard form. And then after that, you identify A, B, and C. And then you use these two formulas. Okay, the first one, it's already in standard form. Our A here is 1, B is negative 9, and C is 8. So the sum of the roots is negative of B over A. So negative of negative 9 over 1, that is positive 9. And the product of the roots is c over a. Our c here is the constant term, that is 8, over a, which is the coefficient of x squared. So that is 8 over 1, which is 8. Number 2, we have negative of 6 over 1. That is negative 6. And the product of the roots is 8. That is c. The c is 8. And then a is 1. Third example, we have b here is positive 1. So we will have negative of 1 over 1. That is negative 1. And the product of the roots is c over a. So c here is negative 30. And our a is still 1. So negative 30 over 1 is negative 30. And then for the fourth one, we have a is 3, b is negative 8, and c is 4. So for negative b over a, that's negative of negative 8 over 3. So that is positive 8/3. And then the product of the roots is c over a. So that is 4 over 3. C over a. For x squared minus 6x plus 13 equals 0, our a here is positive 1, b is negative 6, and c is positive 13. So, sum of the roots is negative of negative 6 over 1, that's positive 6, while the product of the roots is 13 over 1, which is 13. And then for this one, x squared equals 7x plus 2, you will have, or you transform this to standard form. So put 7x plus 2 together with x on the left side of the equation, and you will have x squared minus 7x minus 2 equals 0. Our a here is positive 1, b is negative 7, and c is negative 2. So negative b over a is negative of negative 7 over 1, that's positive 7. And the product of the roots is negative 2 over 1, that is negative 2. And then x squared minus 9, we don't have a term here with x. Therefore, our b here is 0. So our b is 0. So negative of 0 over 1, or that is simply 0. 0 is not a signed number. And then for the product is c over a. The c is the constant term, that is negative 9, over the coefficient of x squared 1 is negative 9. And lastly, 3x squared minus 6x equals 0. A is 3, b is negative 6, while c is 0. So c is 0 because we don't have a constant term here. So c is equal to 0. So for the sum of the roots, we have negative of negative 6 over 3, that is positive 2, while the product of the roots is 0 over 3, that is 0. So don't forget that your quadratic equation should be in standard form. And then identify a, b, and c, and use the formula for the sum of the roots negative b over a, and for the product of the roots c over a. So with this, you don't need to actually find the roots of the quadratic equation. You can identify the sum of the roots or the product of the roots. Let's have some practice. Find the sum and the product of the roots of the following quadratic equations. So we have here 5. Number 1, x squared plus 7x plus 6 equals 0. Number 2, 2x squared minus 5x plus 9 equals 0. Number 3, 3x squared minus x equals negative 5. And then 4x squared plus 9x equals 0. And lastly, 5x squared equals 10. So you have to be careful here that this third equation is not in standard form, as well as this last equation here. This is also not in standard form. Okay, so pause the video and answer the following items. Let us check if your answer is correct. So for number 1, the sum of the roots is negative 7 because that is negative of 7 over 1. So negative b over a. And the product of the roots is 6. So that is 6 over 1. That's c over a. Here, for the sum of the roots of this equation, that's positive 5 halves. And the product is positive 9 halves. For this one, we have to make this negative 5, positive 5, and then put to the left side. So 3x squared minus x plus 5 equals 0. So your b is negative 1, your a is 3, and your c is positive 5. So negative b over a, that's negative of negative 1 over 3, that's positive 1/3. And the product is c over a, that's 5 over 3, or 5/3. For the fourth example, the sum of the roots is negative of b over a. Our a here is 4, b is 9, and c is 0 because we don't have a constant term. So negative b over a, that's negative 9 over 4, or negative 9/4. And for the product of the roots, that's 0 over 4, it's 0. And then the last one, you need to write that in standard form. So it has to be 5x squared minus 10 equals 0. And then your a will be 5, b is 0, and c is negative 10. So for the sum of the roots, that's negative of 0 over 5, that's 0. And then for the product of the roots, that is negative 10 over 5, negative 2. So we have here a total of 10 points. Check your answers and identify your score. For those who got 10, congratulations. And for those who got less than 10, then you can do better next time. So keep on watching the videos and then practicing the exercises given so that you will master the lessons. Okay, let us move to a different question now. Example number 1, find a quadratic equation whose roots are -2 and 9. So, if the roots are -2 and 9, then the quadratic equation can be expressed as a factored form as x plus 2 times x minus 9. So x plus 2 should be a factor because x equals 2 is a solution or a root of the quadratic equation. And then x minus 9 is a factor because x equals 9 is a solution. And then you expand and simplify this. You will have x squared minus 9x plus 2x minus 18 equals 0. Or that is simply x squared minus 7x plus or minus 18 equals 0. Or if you can recall, ax squared plus bx plus c is equals 0 is the standard form of the quadratic equation. And if you divide both sides of the equation by a, divide ax squared by a, you will get x squared. Divide bx by a, you will have b over a x. And then c is, this is going to be c over a equals 0. As what you can see here, we have b over a and c over a. So c over a is the product of the roots, while b over a is the negative of the sum of the roots. So this can be expressed as x squared minus negative b over a x plus c over a. So the quadratic equation, if you know the sum and the product of the roots, can just be x squared minus, this is the sum of the roots, negative b over a, and then you put x plus c over a is the product. The product of the roots equals 0. So you should not forget this, that if you're given with the sum and product of roots or the roots of a quadratic equation, then you can identify the equation by using this. X squared minus sum of the roots, x plus product of the roots equals 0. If we apply that to this example, we will have x squared minus, what is the sum of the roots? The sum of -2 and 9 is +7. And then you put x plus the product, -2 times 9 equals 0. So -2 plus 9 is +7. So x squared minus 7x minus 18 equals 0. You will get the same answer. So in the succeeding examples, we will use this process here, solution number 2. So you just have to recall that x squared minus sum of the roots x plus product of the roots equals 0 is the equation given the roots or sum and product of roots. Find a quadratic equation whose roots are 4 and 8. So recall that x squared minus sum times x plus product equals 0 is the equation. So what is the sum of 4 and 8? That is 12. And then the product is 32. So the equation is x squared minus 12x plus 32 equals 0. Another example, find a quadratic equation whose roots are -3 and -5. So same, x squared minus sum of the roots times x plus the product of the roots equals 0. So the sum is -3 plus -5, that is -8. So x minus -8x plus 15 equals 0 simplifies to x squared plus 8x plus 15 equals 0. So that is the quadratic equation whose roots are -3 and -5. Number 4. Find a quadratic equation whose roots are 6 and 6. So x sub 1 is 6 and x sub 2 is 6. So the sum of 6 and 6 is 12. The product of 6 and 6 is 36. So we have x squared minus 12x plus 36 equals 0. If we have roots 0 and 7, their sum is 7 and their product is 0. So same, x squared minus sum of the roots times x plus product of the roots equals 0. So x squared minus the sum is 7x plus 0 equals 0. Or simply x squared minus 7x equals 0. Number 6, find a quadratic equation whose roots are 2/3 and 1/2. So you should be able to know here how to add and multiply fractions. So same, x squared minus sum of the roots x plus product of the roots equals 0. So the sum of 2/3 and 1/2 is, find the least common denominator. That is 6. That's just 3 times 2 because these are what they call this, relatively prime. So say, find equivalent fraction of 2/3 whose denominator is 6, and find the equivalent fraction of 1/2 whose denominator is 6. So 6 divided by 3, that's 2. So 2 times 2 is 4. So 4/6 is the equivalent fraction of 2/3. And then for 1/2, 6 divided by 2, 3 times 1, that's 3. So 3/6 is the equivalent fraction of 1/2. And these two are already similar fractions. Then we can add the numerators and copy the denominator. So 4/3 or 4/6 plus 3/6 is 7/6. So the sum is 7/6. So x squared minus 7/6 x plus the product 2/3 times 1/2. You can cancel 2. And then you'll be left with 1/3, or that is 1/3. Or, so this can already be your answer. X squared minus 7/6 x plus 1/3 equals 0. But you can find an equivalent equation to this with integral coefficients. That means to say the coefficients are only integers. So we have to multiply the least common denominator of the fractions to both sides of the equation, in this case 6. Multiply each of them by 6. You will get 6x squared minus 7x plus 6 times 1/3 is positive 2. So equals 0. So in this case, the coefficients are integers, no fractions. So this can be your answer. Another example, number 7. Find a quadratic equation whose roots are -1/4 and 3/2. So we already had an example in example number 6, similar to this, because these are fractions. So you can try this yourself. Pause the video and answer yourself. And then please make your coefficients integers only. So we can add to the instruction that find a quadratic equation with integral coefficients whose roots are -1/4 and 3/2. So same, x squared minus sum of the roots x plus product of the roots. And the sum of -1/4 and 3/2 is 5/4. So x squared minus 5/4 x minus, here if you multiply 1 times 3, that's 3, 4 times 2 is 8. So that's -3/8. So x squared minus 5/4 x minus 3/8 equals 0. But since the instruction we added that the coefficients should be integers, we multiply 8 to both sides of the equation. We will get 8x squared minus 10x minus 3 equals 0. Example number 8. Okay, the sum and product of the roots of a quadratic equation are 9 and 2 respectively. Find the quadratic equation. The sum of the roots is 9. The product of the roots is 2. Find the quadratic equation. So we can apply immediately this formula that the equation is x squared minus sum of the roots x plus product of the roots equals 0. So x squared minus the sum is 9 as given in the problem, plus, times x plus the product, which is 2, so plus 2 equals 0. And this is your final answer. So it's very easy if the given is sum and product. Okay, let us have some practice items for this lesson. All the items here are similar to the examples that we had. Number 1, the sum and the product of the roots of a quadratic equation are negative 4 and 2 respectively. Find the quadratic equation. So this item is similar to the last example that we had. Number 2, find a quadratic equation whose roots are 5 and negative 1. Number 3, 6 and 7. Number 4, negative 2 and negative 2. Number 5, 0 and 3. And number 6, 2/5 and 1. Try this yourself. So you have to use the formula that we have for the equation. We have x squared minus sum of the roots x plus product of the roots equals 0. And then if your answers have fractional coefficients, then make them integers. Okay, so here are the answers. Number 1, x squared plus 4x plus 2 equals 0. So x squared minus negative 4x plus 2. So that will be positive 4x. Number 2, we have x squared. The sum is positive 4. So minus 4x plus the product, which is negative 5. So minus 5 equals 0. Number 3, the sum is 13, so x squared minus 13x plus the product of 6 and 7 is 42. Number 4, negative 2 and negative 2, so the sum is negative 4, so x squared minus negative 4x plus the product is 4. So x squared plus 4x plus 4 equals 0. Number 5, we have x squared minus 3x equals 0. That is x squared minus the sum is 3, so minus 3x plus 0 equals 0. And we have x squared minus 3x equals 0. Number 6, x squared. The sum of 2/5 and 1 is 7/5. So you will have x squared minus 7/5 x plus 2/5. And then multiply both sides of the equation by 5 so that we will have integral coefficients. So we will have 5x squared minus 7x plus 2 equals 0. So congratulations for those who got 6 points. That's it for the sum and the product of roots of quadratic equations. Thank you for watching. Comment, like, and subscribe. Bye!